Hello everyone. In the lecture today, I'm going to talk about global climates, specifically the 5 atmospheric processes which control and influence meteorological conditions on Earth. The first atmospheric process that is important here is solar energy. We can think about solar energy as insolation or incoming solar radiation, which is absorbed by the land and water surfaces on the Earth. This heats the Earth's lower atmosphere, which is sort of counterintuitive. We would think that the upper atmosphere, which is closest to the sun, would actually experience more heating. But the reality is that most of the sun's energy passes through the Earth's atmosphere, and then it's absorbed by the surface of the Earth and re-radiated from that surface. Because of that, it's actually warmer the closer you are to the surface of the Earth, and as you go up in altitude, the temperature decreases. So that re-radiated energy then is sometimes trapped by the Earth's atmosphere. So different things within the atmosphere have different abilities to absorb that re-radiated heat. So things like water vapor, carbon dioxide have a great potential to trap that heat. Now that's a natural aspect of the Earth's atmosphere, and this is called the greenhouse effect. There's the natural greenhouse effect that adds a certain amount of degrees to the average Earth's temperature. The concern about things like climate change is the idea that we're adding more of particular types of greenhouse gases to the atmosphere that's trapping more heat than would naturally be kept by the standard level of greenhouse gases. This graphic shows the relationship between sun energy coming into the Earth's atmosphere and how it is absorbed and re-radiated. So you see, as that energy comes in, some of that radiation is reflected by the clouds in the atmosphere, and it doesn't even reach the surface of the Earth. But some of it passes through the atmosphere and is then absorbed by the Earth's surface. So the Earth's surface then re-radiates infrared radiation, so it's a sort of lower wavelength of energy, and that infrared radiation, which we experience as heat, is absorbed by greenhouse gases in the atmosphere, resulting in warming in the lower atmosphere. So some of this infrared radiation then passes through the lower atmosphere and back out into space. That's why the planet doesn't just keep getting hotter and hotter and hotter, because some of it then passes out into space. The amount of incoming solar radiation is related to the Earth's orbit around the sun and the tilt that the planet is on. Because of this tilt, different parts of the surface of the Earth receive more or less direct sunlight depending on the part of the year. You can see that illustrated in this graphic here and read about it in your book as well. So another important factor that influences global climate then is latitude. We can think about lines of latitude as those lines that you see on the globe that would go from east to west, that split the world from the equator north and south. So these lines of latitude have different sort of directness of the incoming solar radiation. So if you look at the graphic here, you can kind of think of it as using a flashlight. If you shine a flashlight beam straight at a surface, you're going to have a concentrated direct beam of light. But if you turn the flashlight so the beam of light is spread over a larger area, it's going to be more diffuse. You're going to have less direct energy. And that's sort of what you see here in terms of the light from the sun shining on the globe. In places around the equator, you're receiving more direct light, a more concentrated area of that energy coming in. So you get actually more energy per meter. As you go into the more northern or southern latitudes, the rays become more oblique. So the rays are spread out over a larger area. They're less concentrated. You're getting less energy per meter. So because of that, then you have differential heating over the surface of the Earth, with the majority of energy and the majority of heating occurring around the equator, and then that lessening as you move further north and south in terms of latitude. So we see that illustrated in things like this map that has the average temperatures for summer and winter respectively around the world. We can see around the equator, around 80 degrees Fahrenheit is the temperature throughout the year. But we see the movement north and south of decreasing temperatures overall, and we can see how the sort of band of 70-degree temperatures moves north and south throughout the year. So the interaction between land and water is another important factor for global climate. And we can think about how land and water have differing abilities to absorb and re-radiate energy. So the land tends to warm up quickly and cool down quickly. We can think about this in terms of continent-sized pieces of land and the folks that have to live in the middle of them. For example, folks in the Midwest United States. So in places like this, you have climates with hot summers and cold winters. So the land heats up quickly in the summer, cools down quickly in the winter. Maritime climates, or climates that are influenced by nearby bodies of water, tend to have a more moderate climate overall. So water absorbs heat quickly and it re-radiates heat quickly, so it cools down more quickly or more slowly. So you tend to have cooler temperatures overall, so not the sort of 100-degree temperatures the Midwest might experience in the summer, but more cool, more breezes off the sea, things like that. And then in winters, not quite as cold a temperature. So here's some examples of these types of climates. On the right, you see a picture of Chicago in the cold winter and the hot summer. And on the left, you see a picture of a place in Italy, which has a fairly moderate temperature throughout the year and is influenced by the Mediterranean Sea. Another factor that influences global climates is global pressure systems. Now, we think about how there's a seasonality that's set up in terms of the amount of incoming solar radiation, how different latitudes are receiving different amounts of heating. And so there's a difference over the surface of the Earth of what areas are heating up and cooling down. So this uneven heating of the Earth creates systems of high and low pressure cells that set up over time. I want to take a second to explain how pressure works. A lot of us might know from watching the weather that when a low pressure system comes into our area, we often experience things like rain. But what's actually happening with high and low pressure is kind of counterintuitive. Of course, warm air rises, and as that air rises, it's getting further from the surface of the Earth and is cooling. As it cools, the moisture in those clouds tend to condense and cause precipitation. So when you have areas of low pressure, the air is actually rising to cause precipitation. When you have areas of high pressure, that air is cooling and descending. Now, when you think of air that is descending or rising, it has to go somewhere. You can see from the figure that as air comes down, it is pushed in either direction as it hits the ground, causing divergent winds. And of course, we can think about how these pressure systems and wind systems might look on the surface of the Earth. So this is a map that shows the sort of standard pressure and wind systems that we see across the globe. So there are high pressure systems associated with around 30 degrees latitude north and south. So areas over places like Hawaii, in the middle of the Atlantic Ocean, in the middle of Siberia, places like that. So these places tend to be dry. You don't have a lot of low pressure, you don't have a lot of precipitation. Around the equator, you have a zone of low pressure. So you have low pressure, which means rising air causing precipitation. And you see that through the areas that receive a lot of rainfall, such as the Amazon rainforest and rainforests throughout Central Africa as well. Then at either pole, you also have high pressure systems set up. And then there are, these winds blowing between that have, have been very historically important to things like navigation, especially when we were traveling by wind power. So you have things like the northeast trade winds that enabled Europeans to travel through wind power to places in the Americas. So then the global wind patterns result from these pressure systems and have an effect on the prevailing wind systems in different areas. So this sets up an overall system of atmospheric circulation where you have trade winds, jet streams, different high tropical zones, and polar fronts. With, of course, we're talking about climate as the sort of average weather for places, and then the day-to-day weather that we see is influenced by these things and much more specific.